Next topic is understand the relation between the perpendicular lines. Now, if two lines are perpendicular to each other, they have a relationship between their gradients. If a line has gradient of m, right, a perpendicular line to it has a gradient of minus 1 over m. This is the main point. If a line has the gradient 2, so the perpendicular line to it has the gradient minus 1 over 2. Okay, you can also say that if two lines are perpendicular, the product of their gradients is equals to minus 1. So you can see that the gradient of line 1 is m and the gradient of line 2 is minus 1 over m. If we multiply these two gradients, your answer will be equals to minus 1. As I gave you the example that if the gradient is 2 and the perpendicular line must have the gradient minus 1 over 2, so the multiplication will gives us minus 1. Okay, work out the gradient of the lines that are perpendicular to the lines with these gradients. So here is the gradient given, that is 3. So what is the perpendicular line has the gradient, so gradient m is equals to 3, so the gradient of the perpendicular line must be minus 1 over 3. How? If the gradient is minus 1 over 3, then when we multiply these two gradients, your answer will be minus 1. Okay. Also, gradient is given as 1 over 2. So what is the gradient of the perpendicular line? That will be minus 2, right? If we multiply it by minus 2, your answer will be equals to minus 1. Understand or not?
Yes.
And in part C, you can see that the gradient given as minus 2 over 5. So if we multiply this minus 2 over 5 by 5 over 2, so you can see that this 5 is cancelled out by this 5, this 2 is cancelled out by this 2, and its answer will be minus 1, which is required. So it means that the perpendicular line has the gradient that is 5 over 2 as given in this part C. Understand?
Yes.
This is your example 6. Next one is example 7. Show that the line y is equals to 3x plus 4 is perpendicular to the line x plus 3y minus 3 is equals to 0. First of all, this is in the this is like the general form of the straight line. We have to convert this equation in general form also. How? First of all, we move this x on the right side and also this constant term on the right side. So it will becomes 3y is equals to minus x plus 3. So after that, we just divide the whole equation by 3. So y is equals to minus 1 over 3x plus 1. Now its form is like y is equals to ax plus b, or you can see you can also say that y is equals to mx plus c. Okay, so after that, the gradient is minus 1 over 3 in this case, and the gradient is 3 in this case. When we multiply these two gradients, your answer will be equals to minus 1. It means that these two lines are perpendicular to each other. The lines are perpendicular because the product of their gradients is equals to minus 1. Understand or not?
Yes.
Next one is the example 8. You can see that work out whether these pairs of lines are parallel, perpendicular, or neither. So we have to calculate the slopes of all lines. So what is the slope of this line? That is minus 2. What is the slope of this line? That is also minus 2. So the slopes, if the slopes are same, you can say that the lines are parallel, right? In part B, you can see that first of all we have to convert this equation into the standard form, that is y minus y is equals to minus 3x plus 2, right? After that, when we divide the whole equation by -1, it will becomes y is equals to 3x minus 2. So it means that its slope is, or its gradient is 3. Next equation is x plus 3y is equal minus 6 is equals to 0. So when we convert this equation, you can see that y is equals to minus 1 over 3x plus 2. So therefore the gradient of this line is minus 1 over 3, and in this case its gradient is 3. So when we multiply these two gradients, your answer is equals to minus 1. So these two lines are perpendicular. This is parallel lines, this is perpendicular line question. Next one is part C, y is equals to 1 over 2x. So here we have not any y-intercept, right? And also when we convert this equation in the standard form, you have the equation y is equals to 2x plus 4. So you can see that here in this equation we have the gradient 2, and in first equation you have the gradient 1 over 2. When we multiply these two gradients, your answer will be equals to simple 1. It means that it is not minus 1. So in this case these two lines are not parallel, not perpendicular. Understand? These two lines are neither parallel nor perpendicular. Any problem?
No.
Okay. Next is the next example, that is example 9. Find an equation of the line that passes through this point. Now the point is given and perpendicular to the line, this one. So we have to find the equation that is perpendicular to this line. So first of all, we have to find the slope of this line, that is simple 2. And what is the slope of the line which is perpendicular to that line? That must be equals to minus 1 over 2, right? Now you can see that this is the slope and this is the point given. We have to put this point and slope into the point slope form, that is y minus y1 is equals to m times x minus x1, right? So you can see that where y1 is basically minus 1 and x1 is basically 3. So you can see that y minus minus 1 is equals to minus 1 over 2 is the gradient into x minus 3. 3 is x1. So when we simplify it, your answer will be y plus 1 is equals to this minus 1 over 2 is multiplied into the bracket. It will becomes minus 1 over 2x plus, because this minus and this minus, when we multiply, your answer will be plus. So it will becomes 3 over 2. This one goes on the right side and subtracted from this 3 over 2. So your answer will be y is equals to minus 1 over 2x plus 1 over 2. This is the equation of the line which is perpendicular to that line and passes through this point. Understand?
Yes.
Next is the exercise. Exercise 3 has total 8 questions. You have to do at least 4 questions from this exercise. Part F, question number 3, part D, question number 4 and 5. So first of all, you have to do the examples. Secondly, you have to do these questions. Okay?
Okay.
Hurry up.